back to what we were doing. Okay, these two chords are congruent. I've drawn two chords, they're both 2 inches long. So it's safe to say that AB is congruent to what? Is there anything else you can say? Just looking at the picture, is there anything else you can guess?
They're the same distance apart from the circle.
Yeah, yeah. It looks like we've cut the same piece off, right?
Yeah.
And that's right, yeah. Yeah, and it's leading. That leads you kind of to where I'm wanting you to lead, or this to lead you to. Yeah, I meant to say that better than that. Point I'm making is, let me ask you this: what new form of measurement have we talked about in this chapter? What? You heard it?
Minor arcs.
Arcs, right? Okay. Now, in that in mind, look at the picture again. What do you think you could say?
AD, BAD.
So you're saying then maybe the measure of arc AB would be congruent, or arc AB would be congruent to what?
Arc CD.
What do you guys think about that? Does that look like they're exactly the same part?
Yes. True.
Okay. And then I'm going to say and vice versa. So, if two arcs are congruent, the chord containing them has to be what? If the two chords in the same circle are congruent, then the what? The minor arcs, and it just the minor arcs, okay? Because they may be angled a different way. The major arcs could end up being different, okay? But the arcs, the minor arcs, are congruent. Does that make sense? Because basically it's going to cut off the exact same size, isn't it? If you had a perfectly circular pizza, if you put a 12-inch ruler on top of the pizza and made it barely touch each side and cut it, and then went to another part of the pizza, did the exact same thing, a 12-inch ruler, cut it, you've cut off what should be two exactly the same sizes of pizza, or cuts, right? Now, you may have a lot of crust, but you cut off the same amount. Do you see the point I'm making? Just as if you cut it right down the middle, it's the same concept. You basically have the two arcs left are the equal, aren't they? Okay? So that's another thing to learn. So, another thing we can do, though, even though, what can I do with each of these, what if I made another segment from the end of each of these? Make a triangle, wouldn't it? And let's call this A, B, C, D. Let's call this point E. We already know that this is congruent to what? We know that this arc is congruent to what? And by the way, that's how we mark arcs. Mm-hmm. Is there anything else you can say is congruent here?
The triangles.
Well, we already stated that this is congruent to that, right?
The triangles are all congruent. They're all a radius.
Well, I would not be more detailed. Eventually, we'll get to there. But,
It's an equal angle.
well, first of all, are those two congruent?
Yes.
Tell me why.
Because they're both radius.
They're both radiuses, aren't they? So isn't that also congruent to that? So by side, the triangles are congruent. But you don't even need to go that far, do you? What I'm trying to get to you is realize that since those arcs are congruent, isn't that angle going to be congruent to that angle? Because it's the central angle that contains this arc. So if this arc was 80 degrees, this arc would be what? 80 degrees, wouldn't it? What would it make this angle? 80 degrees. What would it make this angle?
So what if the
Well, remember, the measure of an arc is found by finding the measure of the central angle containing it. And isn't this a central angle? Because it goes through the center, and it's like two arms holding that arc. Okay, same thing here. Another thing you can say, since these are both radiuses, these two are congruent. What do we know? In a triangle, if two sides are congruent, then the opposite angles are what? So if this is 80, that means this one is what? How much is left for both of them to be?
40. Oh, sorry. I was thinking.
For both of them, how much is left for both of them? How much is left for both of them to be? Both of them.
Oh,
This uses up 80 of the what? 180. So for both of these, there's how many degrees left?
100.
100.
I see what you're saying.
For both of these, there's 100 degrees left. Since they're equal, now you would divide that to divide them evenly would make this what? 50 degrees, and this what? What would it make this one? And this one? Boy. All of this, from knowing that's congruent to that, that's congruent to that, and then telling you that's 80, I found all that information. The thing in pink is the only thing you started with. This and that. All the other stuff you found. And if you think about it, because circles are so perfect, it is a perfect circle, right? There's going to be a lot of things that are going to be symmetrical, that are going to be the same, because it's the same distance from the center all the way around. That's what makes it a circle. Maybe that's a little easier to see. Okay? So that's a lot of stuff just for one fact, isn't it?
So what were we trying to find?
Sean.
I was showing you all the information you can find by just saying what?
AB.
These are what? Congruent. How much that can lead you to. Because you're going to have situations like this. You're going to have to be able to look at this and realize if it goes from the center to the outside, what is it called? And they're always the same inside the same circle, are they not? Okay. So this is kind of our first kind of big fact here. We're going to go down and do some more here. So you're going to need to draw another circle. And I'll draw you, show you some more interesting things that happen with chords and circles. Okay. I am going to draw another 2-inch chord. Well, no, how about I make this one 4, or let's go we'll go 2 inches again. Okay. Now, can anybody tell probably what did I draw here? I drew a diameter.
At this time, all AM Tech students who'd like to meet with the Tulsa Community College representative report to the Ram statue in the New Commons at this time. Thank you.
What kind of angle do you think I made here?
Right. 2 right
Yes. So what could I say?
You could say.
Let's say, let's make this D. That's that point right there.
Let's see.
Let's make that E and make that F.
That A to F, the arc AF is 90.
No. Not at all.
Is it?
No.
How?
Well, EF is semicircle.
Okay. Everybody stop writing what you're writing. And pay attention. First things first. We agree that FE, what's that sign mean?
Parallel.
Perpendicular to AB. Would everyone agree with that? They intersect to form. We also, what could we call FE is a what?
Semicircle.
No, FE is a segment. In no way is it ever a circle.
Oh, diameter.
FE is a what? Diameter. So we've got two things that I said were true. Then I'm going to show you something that happens. This is our if. If they're perpendicular, and I guess I should add in here, AB is a what? Chord. So, then, is it what, just by looking at it, knowing that my measurements are right, what do you think you could say? What do you think? Just look at the picture and tell me something that happens. I know I tell you not to go by what it looks like, but what does it look like maybe happens? If you were guessing.
Cut into like 4 halves.
Hmm?
It gets cut into 4 segments.
I said AB equals CE. There's the same thing as CE.
No.
A equal.
Think about it. Couldn't this get bigger and move up here? And it still be a chord? So what does it look like happens?
Is it?
You were kind of on the right track.
AB equals C.
Nope.
What about 80?
Because if I moved it up to here, it wouldn't be the same, would it?
What about if 80 equals 80? What?
Very, very good.
What? I don't.
Oh, that makes sense, because it cuts it in half. so
Right.
Doesn't it look like it cuts this in half?
Yeah.
Well, I just feel stupid.
Doesn't it look like it? I mean, guys, look at this. Doesn't it look like this piece is exactly the same size as what?
AD.
This piece right here?
I thought you did have it like that.
But I never said that it was, right? I said all I did is I drew what? Two perpendicular segments, right? Everyone agree? I drew two perpendicular segments. I drew one of them as a what? Diameter. And I drew one of them as a chord. Now, and then I said, what happens? You got, and that's the thing. Keep it simple. You kind of looked over the obvious and tried to make it something fancy when really all that looks like it happened is it what?
That's why I said it.
So then we could say the diameter bisects that chord.
And that's it?
Yep. So anytime a diameter is perpendicular to a chord, what does it do to that chord?
Bisects it.
Cuts it in what?
Half.
I want you to think about something. What do you think the chances of you getting a problem that looks something like this? What do you think there's a chance of that happening?
Very good.
What have I created? Two what?
It's still like watching things.
Yes. But what have I created? Two what? Right triangles. What if is there another relationship there maybe?
Side angle side.
No. I'm asking you this.
Well, then you make two.
What is there anything else I could say is congruent?
The CD.
CD.
The CD.
Isn't this got to be congruent to that? Tell me why.
Because you just make
They're both what?
Radiuses.
Radiuses.
And then
There-
CD.
And isn't this congruent to itself? All three sides are congruent of those two triangles, then what? The two triangles are congruent. So this is congruent to what? That. That is congruent to what?
And then you can do a piece.
All kinds of stuff you can make there, isn't there? Hey, guess what they could also do?
Oh, they won't know.
Make another triangle, or another baby pillar.
Could I make two other little baby right triangles?
Yeah, but then.
Are those two baby right triangles?
Yeah.
And you could keep.
And since the angles here, the central angles are congruent, what do these chords have to be? Then this is congruent to what? That, and those are both right. So we got two more congruent triangles.
And then the.
So they could tell you like one thing and it could lead you to a bunch, couldn't it?
And this is
Yeah.
due tomorrow.
He doesn't even get in those signs.
Would you listen? So as you can see, a lot of different little things happen, huh?
Does, on the lines, is that four?
Yeah. I'm just trying to say that basically what I'm saying is when you have a situation like this triangle is congruent to what? This triangle right here. Agreed? And this triangle created is congruent to what? This triangle created right here. Make sense? A lot of the things we do in the rest of this chapter will be based on this. Has everybody got all that down? Tell you what, I'll make copies. Okay? Now, guess what? There's another concept.
I feel like every time you accomplish one thing,
There's another thing.
It's called education. It's called a class. Oh, it's called somebody's going to whine about something. I know. Trust me, I coach baseball players. I know all about
Hey,
listening to whining.
what does that mean?
It means
Means you went.
a bunch of whiners.
I'll take that as a yes.
Now, I'm going to draw two congruent chords again. I'm going to go with 2-inch chords again. Trying to see if I've got the center right. it's more like right here. Make the center bigger, then I know I'm right, right? Somewhere it's right. Okay. Tell you what, that's bugging me. So, I am just going to start over with what I know will be a perfect circle, using my trusty compass. And I know that's the center. Isn't that beautiful?
Majestic.
I feel like you're drawing this thing.
It's the only time I ever draw. It's okay to recognize the talent, I understand. A, B, C, D. AB is congruent to CD. Okay,
Wait, are you gonna finish this up too?
and let's call this center E. What do you think you can tell me about those chords with respect to E?
So that must mean they're equidistant.
Huh?
They're equidistant.
Equidistant apart?
Yes.
Try to take
You would be exactly right.
Thank you, Coach.
Now, how do I measure that though, or how do I draw it?
The compass.
Well,
We go through the roof.
you guys remember when I drew that pretty picture of an airplane
Yeah.
flying
Again.
up in the air, and then you had the ground down here? How does Bob the pilot measure his altitude?
Elevation and depression.
Well, he could measure his way down on an angle, but how does Bob the pilot measure how high he is from the ground? Straight down? How do we measure, what does straight down mean? Huh? Straight down, it means perpendicular to the ground, doesn't it?
Yes.
Because that's the shortest, the fastest I can get straight down to the ground, right? And if you remember, I talked about how do you measure the distance from a point to a line? You measure it along a what? Perpendicular line. So, what this theorem says is that if two chords are congruent, then the perpendicular distance from the center to said chord are the same. In other words, this is congruent to what? And that makes sense, doesn't it? But you know what's great about that? You want to hear the fun part?
Yeah.
Watch. What could they also do?
Make more triangles. Whoa.
That's a lot of triangles.
I could draw 5, couldn't I?
5.
Or I could draw 4 congruent triangles, but I could draw 2 sets.
Whoa. Looks like
Because I couldn't I draw up here and connect it, but still. Even still, you guys get the point I'm making. These are all radius, so this is congruent to this, is congruent to this, is congruent to what?
that.
And since it's perpendicular, and if I extended this, is this not a diameter?
Yeah, it is.
So I know it cuts this one in half, so this is congruent to what?
That.
And guess what? This is congruent to what?
That.
This is congruent to what?
That. Man, this is
And this is congruent to that, and this is congruent to what?
This and that.
Whole lot going on there, isn't there?
sure is.
But all of it based on this fact, that if the perpendicular distance, if those two chords are congruent, These two are what? Congruent.
You're recording this, correct?
Yes. Why? You want to be able to watch me draw that plane over and over again, don't you?
Yeah.
Okay. All right. I would like you to start
1 through 5.
by doing numbers 1 through 5 today,
I'll say it.
4 tomorrow. We will discuss those tomorrow.
Sounds.
However, later the entire assignment will be numbers 1 through 14.
So you want us to do one?
Is that just it? 1 through 14?
22, 23, 31, 32, and 33. Write problems, draw figures, show all steps and work. I would suggest a certain amount of tracing going on.
Tracy.
If you're really hung up, or use pencil, make your pictures, but you know, the one thing that's tough about circles is if you make your circles too bad and draw your stuff on there, it can get a little confusing. Don't kill yourself trying to make them perfect though, okay? The key is understanding the material. If you write very lightly in pencil in the book and erase it, you know, you can mark some things in the book on the good picture, okay?